Okay, so one of the requests during the last couple of days was to go through a few more examples of Punnett squares and pedigrees, so I've created this little presentation to do that. The first question says, in humans, brown eyes are dominant over blue eyes. What type of offspring would you expect if you crossed a heterozygous brown-eyed person and a heterozygous brown-eyed person? So if we have a look at the question, we can see that brown eyes are dominant to blue eyes. We can also see from the question we want to cross a heterozygous brown and a heterozygous brown. So we know that heterozygous means that they have one of each of the alleles. So our cross will be between a big B little b and a big B little b. So we need to draw our Punnett square, put our alleles in here, do the crosses, big B little b, big B little b, oops, that should be big B, big B, big B little b, and little b little b. So what type of offspring would we expect if we cross these two? So we can see here we have 3 brown eyes to 1 blue-eyed offspring. Okay, moving on. The next question says, a widow's peak hairline is dominant to straight hair. Cross a heterozygous widow's peak person with a straight hairline person. So again, we can see that a widow's peak is dominant, and this time we're crossing a heterozygous with a straight-haired person. So our heterozygous widowed peak hairline person is going to have at least one dominant allele, so I'm going to use H's because they're easy to see the difference. So one big, one little, and our straight hairline person has to be homozygous recessive. So if we draw up our Punnett square again, big H, little h, and little h, little h, we do our cross, little h, big H, little h, and little h, little h. Okay, so here we can see we have 50% of our offspring will have a widow's peak, and 50% will have straight hairline. Okay, let's move on to the next one. So in garden peas, round peas are dominant to wrinkled peas. If you crossed a homozygous dominant and a homozygous recessive, what would be the genotype and phenotype of the offspring? So we can see again in the question, round peas are dominant. If you crossed a homozygous dominant and a homozygous recessive, when we're looking for the genotype and the phenotype of the offspring. So our homozygous dominant round is going to be big R, as homozygous is 2 of the same, and homozygous recessive is little r. So let's draw up our Punnett square, big R, cross with little r, and we do our cross, big R, little r, big R, little r, big R, little r, big R, little r. So the question is asking us for the genotypes. So the genotypes, excuse my writing, is all big R, little r, and the phenotype is all round. Okay, so the reason that they're all round is every single one of our offspring contains that dominant allele for the round seeds. Okay, so in dogs there is an hereditary deafness caused by a recessive gene, little d. A kennel owner has a male dog that she wants to use for breeding purposes if possible. The dog can hear, so the owner knows his genotype is either big D, or big D, little d. If the dog's genotype is big D, little d, the owner does not wish to use him for breeding so that the deafness gene will not be passed on. This can be tested by breeding the dog to a deaf female. Draw the Punnett squares to illustrate these two possible crosses. In each case, what percentage or how many of the offspring would be expected to be hearing and how many would be expected to be deaf? How could we tell the genotype of this male dog? Also, using Punnett squares, show how 2 hearing dogs could produce deaf offspring. So before we go anywhere, we need to find out what alleles our individual dogs can pass on. So the gametes of a deaf female, as we know, she's little d, so she will only be able to pass on little d gametes. Now a deaf male is going to do the same and only be able to pass on little d's, as he is also homozygous recessive. Now the gametes from our normal male are going to depend on whether he is homozygous dominant or whether he's heterozygous. If he is homozygous dominant, he's only going to be able to pass on big D's. However, if he is heterozygous, he's also going to be able to pass on little d's. Now if we're going to cross between a deaf dog and a normal dog, okay, we're going to have to do two Punnett squares, as we can have two genotypes for our normal dog being big D, or big D, little d. And that's what the owner wants to know, whether her male dog is big D, or big D, little d. So let's do big D first. So we have a deaf dog, so their genotype is little d, and the genotype of our deaf dog, is we're using big D first. So we do our crosses and we find that all of our offspring are big D, little d. So the percentage of hearing dogs is 100% hearing, and our percentage of deaf is 0. Now if we're going to do our cross between our heterozygous normal dog and our deaf dog, draw up our Punnett square, little d, and big D, little d. So big D, little d, big D, little d, little d, and little d. So now, as a result of this cross, our percentage hearing is deaf is 50%, and our percentage hearing is 50%, and our percentage deaf is also 50%. So the question asked us at one point, how could you tell the genotype of the male dog? And that would be, if we have any deaf puppies as a result of a cross between our normal dog and our deaf female, then we know that he is going to be deaf as well. We also now need to do a cross between two deaf dogs, which we know are both little d. So we draw up our Punnett square, little d, and little d. We do our cross and we find that all of our dogs are little d, which means that 100% of them are deaf and 0% of them are hearing. So that's why the breeder wants to get rid of, to make sure that her male dog is not heterozygous, because eventually you're going to end up with puppies that are little d, and eventually you're going to end up with a whole breed of deaf puppies. The end of the question then asked us how we could produce a deaf dog between two hearing dogs. So we know that the deaf genotype is little d, so that is going to be one of the 4 genotypes that we have resulting, which means our parents need to have at least one of these recessive alleles. So our hearing dogs could either be big D, or big D, little d. So if we want our little d's to show up in our future generations, we need to make sure that our parents have that gene. So we need to draw up our Punnett square between our two heterozygous parents. And we can see, as a result, we have our deaf puppies coming from here. So by having our heterozygous parents gives us the result of a deaf puppy.